channel Java with hawa. So today we're going to be solving LeetCode number 1647, minimum deletions to make character frequencies unique. So it says a string S is called good if there are no two different characters in S that have the same frequency. Given a string S, return the minimum number of characters you need to delete to make S good. The frequency of a character in a string is the number of times it appears in the string. For example, in the string AAB, the frequency of A is 2, while the frequency of B is 1. So in example 1 here, they give us AAB again. And we need to make 0 deletions because it's already good. We have 2 A's and 1 B. If we had 2 A's and 2 B's, then there would be a problem and we'd have to delete either 1 A or 1 B to make the string good. No. Yeah, to make this string good. So example 2, we have 3 A's, 3 B's, and then 2 C's. So here we have 3 occurrences of A's, so we can't have 3 occurrences of B's. So we'll need to delete 1 B, right? So that's 1 deletion. So now we have 2 occurrences of B's and 2 occurrences of C's. So now we need to delete either 1 B or 1 C to make this nice, to make this good. So we have our output will be 2 minimum deletions to make this string good. And then we have another example here. So they don't always have to appear in consecutive order, by the way. So here we have CEA, BAA, CB, and there's that. So, and then S contains only lowercase English letters, and then here's our constraints. So I'm gonna use the whiteboard here to kind of illustrate what's going on. So I'm gonna use this example here. So if we have A, B, 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 C, and C. So here we're gonna say let F represent the number of expected deletions. So expected, okay, it's hard to type. It's hard to write on this. Expected deletions, right? So now, like, let's say for example, we decide to traverse through this string. So we'll say, okay, we have three occurrences of A. So right now, our expected, sorry, I guess this shouldn't be expected deletion, just the expected occurrence number, I should say. So expected occurrence, not deletion, sorry about that, forget that. So expected occurrences. So right now, F equals 3 because we have 3 occurrences of A. So we know that in our string, there can't be any other characters with the occurrence of 3. So our expected occurrence for all the rest of the characters, F, should be updated to 3 minus 1, 2. So if that doesn't make sense, so okay, here we have 3 A's, right? So we know, okay, since we have 3 A's, if we want this string to be good, there's no way we can have any other character in here with 3 occurrences. So we need to minus 3 by 1 because now we have 2, and right now 2 is the character occurrence number that will satisfy a good string. So if we keep going and we see B has 3 occurrences, so that doesn't satisfy. So we'll know we'll need to delete 1 B to get to 2. So right now, deletions, so I'll say deletions. Wow, this is really bad handwriting. Deletions right now equals 1. So we have to delete 1 B. So after we delete this B, we check our C's, and there's 2 before we delete that, now that we have 2 occurrences of B, we need to update our expected occurrences to 1, right? Because we'll say, okay, since B has 2 occurrences, no other character in our string can have 2 occurrences, so what can it have? 1 occurrence. So now we update this to 1, and we update this to 1, sorry, and then we check C. How many occurrences of C are there? So there's 2 occurrences of C, but to make this string good, we can only have 1 occurrence of C. So we delete, that's the minimum at least. So we can delete 1 C to fulfill this. And now we have 3 A's. So we'll have 3 A's, 2 B's, and 1 C. So and by the way, after we deleted 1 C, we had to update the deletions. So now we have minimum 2 deletions, and that's our output. So Yeah, hopefully that made sense. So I'm gonna erase this and kind of go through the approach, and then we'll see where we go from there. So, all right. So we have A, B, C, and C. So the idea is, since we can only use English lowercase English letters, we can initialize. We can make some kind of hash table. Like we can use an array, just something to map the frequency of each character to its index. So something just to keep track of the frequency of each character. So since our constraints are only English lowercase letters, we can initialize some array. We'll say frequency. We'll call it frequency to size 26 because there's 26 letters in the alphabet. So this will go up to from index 0 to index 25. So we'll say, okay, for each character in our string, for each character, go to the index that it maps to in our array and increment the value at that index. So remember that arrays are auto initialized to 0 in Java. So each entry here will be 0. So let's just say 0, 0, 0, dot 25, 26 times. So now let's map these characters to their indexes and the number of occurrences they have. So A, B, and C, and then dot. These are going to be zeros, but I'm not going to write those. So we'll say, okay, there's one occurrence of A, right? So we start with one occurrence of A, and we say, okay, go to the index A and increment the value at that. So we know it's auto initialized to 0, so we say increment that, so 0 plus plus, so this will become 1. And then we go to the next one, here, and the next one, so now we see, okay, we have 3 occurrences of A. Then we go to B, we do the same thing, and we map it to its index, so 3 occurrences of B. And then we go to C, and we do the same thing, so we know we have 2 occurrences of C. And then the rest is all zeros. So now what we can do is we can sort this array so that we can have the largest value at the end. So we can say arrays.sort, so we'll have 3, 3, 2, and the rest will be zeros. So now is when we can actually implement our logic to find, okay, what is the minimum number of deletions that we have to do to make this a good string. So what we'll do is we'll basically kind of, how can I explain this? Okay, so let me think about this. Hold on one second. Okay, so our expected frequency, which is our largest frequency that we have, will be in index 25, right? It will be the last element in our array because we've sorted the array. So we'll say, okay, expected frequency equals our frequency table or array at index 25. All right, so now we'll traverse through the elements of the array, starting from this index all the way down. We'll decrement I, and we'll say, okay, if the array, okay, so if the value at the index equals our expected frequency, so here we start at, so we'll start at I equals 25, I is greater than or equal to 0, I minus minus, so you know where I'm starting. And then in here is where we'll have all our logic. But I'm not going to write that because it's hard to write with this mouse. So, okay, we'll start traversing, right? So we'll have I equals 25. We'll say, okay, if the expected frequency, if the frequency table at index I equals our expected frequency, then just set expected frequency equal to the frequency table. There's not much change to do. But if and then also after each iteration, you need to do this. At the end, you have something like if expected frequency. It's so hard to write. This is expected frequency. If it's greater than 0, then minus minus after each iteration. Because the point is, if this was your expected frequency of 3, then your next expected frequency should be 2, like we discussed earlier. So if f equaled 3, then we can minus 1 because we know all the other characters need to have either 2 or, okay, hold on, I need to grab my charger. Shoot. Okay. Sorry about that. So if expected, so like I said, so if our expected frequency was 3, then we know that our new expected frequency needs to be 1 less because all the other values cannot be 3. And they have to either be 2 or 1 or 0. Um, so yeah, I hope that makes sense. 1 second. This is really unprofessional, but I don't know how to edit videos. So I will not be editing this part out. Okay, so now we have, so we're gonna minus, but now for the actual logic part that everybody's waiting for. So we'll say, okay, if, so okay, we said if, so first we're actually gonna check if our frequency, oh my gosh, it's what a mess. So we'll check if our frequency table at our index I equals 0. Because we know this is sorted, if this equals 0, we'll know there are no more other frequencies to check, so we'll just break out of this loop and return what we need to return. So we'll also have something to keep track of the result. So here I'll say int result equals 0. So now we'll say, okay, else if our frequency at I is greater than our expected frequency, okay, if frequency at I is greater than expected frequency, then we need to add to our, that means we have to do a deletion. How many deletions do we have to do? Well, let's see. So we're going to add to our result the number of deletions that we need to do. So let's say our expected frequency was 3 here, and let's say we had a number 4 here. So here, if this was number 4, our expected deletions would be 4 minus 3. Well, actually, it would be 4 minus 2, because we would apply this here, but it's getting kind of confusing. So let's just say it would be 4 minus the expected frequency, whatever that was. So in this case, 4 minus 2, which would be 2. So we'd add 2 to our result. So hopefully that makes sense. I'm not the best at explaining this. So result plus equals frequency at I minus the expected frequency. And then else if the, let's see. So else if I was gonna say if the frequency at I equals the expected frequency, then we don't have to do much. That means it's right, and that means, okay, that's our new expected frequency. And then else, meaning if it's less than that, so else our expected frequency just updates to the next frequency that we are on. So we'll say frequency at I, no, we'll say expected frequency equals frequency at I. So this is really hard to draw out, so I'm just gonna go start coding it, and hopefully it will make sense when we do that. So the first thing we did, we initialized our array of size 26 to basically act as a hash table and map the frequency of each character to its index. So int, what is it called? Okay, I'll say char frequency table equals new int size 26. And then we need to add the characters of our string into that char frequency table. So we'll say for every character C in our s.toChar array, then map it to its value, the number of occurrences. So just increment the amount of times so every time you see the character, increment the value at its corresponding index. Is basically what I'm trying to say. So, okay, how would I code that? So for char C, S dot to char array. Okay, so every character that we see in S, say char frequency table, and since it's lowercase, is this how you spell it? Yeah, frequency table. And since it's lowercase English letters, we can do some, what is it? Character math. I don't remember what it's called. So we'll do take that character and minus a lowercase a to get the actual corresponding index, and that will give us what we need to get. So we'll say char at that index plus plus. So that's it for populating the char array. So after that, we'll just sort that array. So we'll say arrays.sort. Um, arrays.sort. What are we sorting? Oh, the char frequency table. Sorry, I'm so out of it today. So arrays.sort char frequency table. So now we should have a visual representation of something that looks like this, right? A sorted char table where we can now start comparing our frequencies. So, okay, this is a different problem. Ignore this. So, let's see. So we're gonna say wait. So let's initialize our variable. So we'll say int expected frequency equals our char frequency table at index 25, because that's the last value in our char frequency table, and since it's sorted, that is corresponds to the largest value in our frequency table. So we'll also have an int result equals 0, and that's what we'll be returning in the end. So here I'll just have return result. And now we can get started. So I'll say for int I equals 25, I is greater than or equal to 0, I minus minus. And I'll say first I'll check if our char frequency table at index I equals 0, we'll know that there's no more characters to check their frequency or look for. So because remember, the key is that this is sorted. I don't know how to get around this if it's not sorted. I'm sure there's a way to do this without sorting the array, but I'm using that way because that's the only way I could think of. So if frequency, oh my god. So if char, I'm sorry guys. So if char frequency table at I equals, what does it equal again? Okay, the expected frequency. Oh my god, I should probably re-record this, but I don't think I will. Equals our expected, oh my god, I'm so sorry, not expected frequency. If it equals 0, then we need to break out of the loop. Let me just look at this. I'm just going to look at the pictures because, okay, so I said, okay, check if it equals 0, then break. And then we check if it's greater than our expected frequency. And then we check if all other cases. Okay, awesome. So if it equals 0, just break out of the loop because we know we're done checking. Else, if the char frequency table at I is greater than our expected frequency, then result plus equals. So result plus equals our char frequency table at I minus the expected frequency, because that's how much deletions we will need to do to get a good string. So we add that to the result, and then we say else. Oh, I'm sorry. There's one more check I was gonna do here. So if char frequency table at I is equal to our expected frequency, then then just set expected frequency equal actually, isn't that the same thing as what I would do in my else statement? We'll see. We actually might not need this part. I'm just kind of struggling to think right now, but expected frequency would equal char frequency table at I. I don't think I need this, but we'll see. Else, let's see. So else we'll just, we'll set, pretty sure that's the same thing. Okay, I'll see at the end. So now after our logic is done, we're adding to our result the amount of deletions that we need to do. Now we actually, like I said earlier, we need to decrement the, we need to decrement the value of the expected frequency So if it's greater than zero, because the lowest possible deletions we can have is zero, so we can't go negative. So that's why we have this check here if it's greater than zero. So we'll say if the expected frequency is greater than zero, then decrement it, because that means all the rest of the characters um, have to be either minimum need to be that expected frequency. So expected frequency minus minus, and then we'll just I don't need this. I don't believe I need that. So basically, let me just look at this picture. So I'm saying if this equals our expected frequency, then do nothing basically. Expected frequency equals this. And then also this was, if it's less than, just update your expected frequency to this. Okay, so I don't think I need that. So let's just let me double check this here. Alright. I'm gonna run this, see what we get. Okay. So AAB worked. Let's submit and see what happens. Okay, so it worked. Hopefully that made sense. I mean, if you have any questions, let me know. But this one is like pretty simple, but it's still very hard to grasp. It took me a little while, to be honest. And I also, oh, this is O of n time complexity, by the way, because we are adding all these elements to our char frequency array. We could argue that making our char frequency table is constant space, because we know that it's only size 26 at most. So yeah, hopefully you enjoyed this. See you next time.